Hello everyone, and welcome to our third MEXA Accelerator Workshop. I'm Joana from Neuromatch, and I'll be your facilitator today. Today's session is focused on project code and data management. So the idea is that today you explore tools and strategies for collaborative, reproducible research across your institutions. And so this is a very important area to ensure that your work is transparent, shareable, and that it's aligned with Wellcome's expectations. So before we start, just a quick walkthrough of today's agenda. So we'll start with some insights from Wellcome, and I'll introduce you to Greg in a moment, and there'll be some time for Q&A. Then I will share very quickly the results of the participants' current practices and challenges. Then we'll have our fantastic three experts speakers sharing practical tools and strategies with you for open and reproducible research. Here they are, and I'll introduce them later as well. Then we'll move into the breakout room. So there you'll be having more hands-on interactive discussions in smaller groups, and you'll be able to share your challenges, try some tools, and get feedback both from the experts and from your peers, hopefully. And then we'll do a quick group share back and an open Q&A at the end, and we'll finish with what's next. Just to mention also that we're also joined today by Laura from the Neuromatch team and by our colleagues at Wellcome Trust. So thank you everyone that is participating and supporting the event today. So by now you already know very well all the housekeeping rules, but just a quick reminder to stay muted if you're not speaking. And when we do the Q&A sessions, either use the raise hand option on Zoom and introduce yourself if you want to speak, or use the chat to write your questions. We'll be checking the chat throughout the event, so don't hesitate to use it. Our tech support today will be Laura, so if you have any issues, please DM Laura. Also note that we are recording this event, and be kind to each other. So with that, I'm delighted to hand over to Greg West. I'll stop sharing my slides. I'll invite Greg to share his slides. So Greg is a senior funding manager at Wellcome, and today we'll be sharing an overview of the applicant guidelines for this call and a little bit also about the Wellcome's expectations for the outputs management plan. Over to you, Greg.
Hello. Yeah, hopefully everything I'm sharing isn't that new to everyone. If you had a chance to look at some of the guidance we circulated a few weeks back, but let's see. Hopefully there's a blue slide on the screen.
Yes.
Cool, perfect. Yeah, so as Joanna said, we're just going to kind of go over the core guidance document we shared, and then just hopefully preemptively answer some questions I expect you will kind of have. So as a reminder, so this is a funding call. It's a one-off competitive funding opportunity designed to support high-impact short-term research projects lasting up to 2 years. The award size is up to £3 million, and that's the maximum that we'll be awarding per award. It's not like a target. So any of the proposed work should be like the proposed cost should be in relation to like the scope and size of the award you're anticipating. So the scale of the proposed project, and should be able to justify any of the request costs. Yeah. So hopefully by now everyone's already been able to access the application forms. They're initially only open to the lead applicants on the Wellcome funding platform. And once logged into the Wellcome funding platform, the leads can then invite the rest of their co-applicants to help complete the form and then begin to complete their own CV details. So all co-applicants have to complete their entire sections before it can be submitted. And the deadline we've got is the 2nd of December 2025, and that's the deadline to submit on the Wellcome funding platform, and that's submitted by your host organization. So you may have some internal deadlines before that, so speak to them sooner rather than later, just so you're aware of when that will be. And your host organization will be responsible to submitting it to Wellcome. So when submitting your application, it'll undergo some internal review by Wellcome staff, so that'll be ensure in eligibility and alignment with the Wellcome policy, the call itself. So there may be some clarification questions asked once it's submitted, but to just kind of avoid that back and forth, it's a good idea to try and read all of that guidance up front whilst completing the form. And then just go on to the kind of the eligibility. Hopefully everyone is already aware of all of this, as we are quite far in now. So eligibility is restricted just to the teams who have been invited to this from the accelerator stage. So those successful preliminary applications. The lead applicants must have a permanent, open-ended or long-term role and contract or the guarantee of one, and they must be based at an eligible organisation that can sign up to Wellcome's grant conditions. The administering organisation could be based anywhere in the world except for mainland China. Your team competition, so your teams can include up to 7 co-applicants from diverse disciplines based at an eligible organisation in any country, again, except for mainland China, and your team should be the appropriate size for the proposed project. So each team, as I said, can include up to 7 applicants, and you must collectively possess expertise in mental health, generative AI, lived experience, and clinical or software engineering if relevant. And it's just really to help ensure that proposals are grounded in diverse interdisciplinary knowledge and are capable of addressing the complex health challenges in mental health research. Just whistle stop through the assessment criteria. So applications evaluated based on 4 weighted criteria. So this is what the committee will be using when they are reviewing the proposals and making those funding recommendations to Wellcome. So the first is the potential for impact and feasibility, and that's weighted at 40% of the total marks. And that's really to assess the novelty and scalability of the proposed research, its responsiveness to lived experience and robustness of its methodology and ethical safeguards. The second is the team skills and experience. So that's considering the multidisciplinary composition and relevant expertise of the team and whether they have the capabilities kind of deliver on what they're proposing. The third is your lived experience involvement. So that's evaluating the strategic inclusion of lived experience experts in leadership and in governance roles with appropriate compensation and clear rationale. And then the fourth, but not least, is the research environment and culture, and that's examining the team's commitment to inclusivity, ethical conduct, governance, and data management. So at top of being inside the application form, there are some pages on the Wellcome website about what that means, what we are looking for when assessing research environment and culture. So if you have a moment, I'd recommend having a skim on that as well. And this is really just all done. So all of those aspects taken into consideration and all be discussed at the meeting by the advisory panel. It's just kind of how that would be done. Cool. Yeah, and then very briefly onto outputs, management and sharing. So this is again another section on the form. So applicants must provide a comprehensive plan for managing and sharing research outputs. That includes a data, software and materials plan, and it should be made available with minimal restrictions to maximize health benefits. So one thing we are actively do at Wellcome is encourage open access publishing, and the intellectual property management must align with Wellcome's policies. So teams working with commercial entities, like as with Google or DeepMind, would adhere to additional conditions regarding IP and commercialization. We can share those in advance if you need to. Otherwise, the normal IP conditions and commercialization policies are on our website. So the outputs management plan should detail how your outputs will be stored, accessed, and used by the research community and other stakeholders, and just ensures transparency, reproducibility, and potential for downstream impact beyond the funding period. The outputs may be shared with end users openly or otherwise, or be made available commercially or by licensing for a fee. So we kind of expect you guys as the experts to manage that in what you think is going to maximize human impact and have the biggest adoption into the community. So the outputs management plan must set out which approach is most likely to maximize the adoption and use of the output by the wider research community and a resulting health benefit. For example, if you're creating a new software tool, an open approach might be appropriate if others could make immediate and sustained use of it, for example, under a GNU general public license or other license approved by the open source initiative. However, a commercial approach might be better for your particular use case if you need further funding or a commercial partner to develop, market, distribute, or support the ongoing use of the software. And you should also really consider whether the output would have greater value to the research community if it's incorporated into an existing commercial product or an existing open resource, rather than making it a standalone product. So I've included a link there to our outputs management plan page. It's again super easy to find on the Wellcome website, and that kind of gives a bit more information on what you can kind of expect, what it is we're looking for, and what compliance and what good outputs management looks like for us. I've also given a few things just to consider whilst you're coming up with those plans. So some things we've put here is like green algorithms. So it's a carbon footprint calculator and reference for more environmentally sustainable computational science. And again, when you're drafting your proposals, it's like reporting on bias. Like, have you considered reporting on bias and representing this of the training data, the model weights release, privacy measures, e.g., is there any noise added to training data for privacy, and what impact does it have on development? And then responsible handover, i.e., the governance once it goes beyond the end of the award. And then briefly touching on the costs. Again, I think these are the most likely questions you'll have, is around probably your own salaries and eligibility of the administering organizations. So the administering organizations can be based anywhere in the world except mainland China. It could be a higher education institution, a research institute, or a non-academic healthcare organization, a not-for-profit or non-governmental research organization. Commercial organizations are not eligible to be the administering organization. However, co-applicants and collaborators can be based at those organizations. And then this is just for the leads for the first point. So in the UK or Republic of Ireland, lead applicants employed by universities or research institutes cannot claim their salary, but those in charities or NGOs may be able to claim their salary depending on the nature of their contracts. And if you're outside the UK or Republic of Ireland, it is claimable for leads if the contract requires external funding and the organisation guarantees support for the remainder of their time and for the duration of the award. And then again, for the co-applicants, they can claim their salary, again, based on their contract type, and they must be able to commit at least 10% of their time to be eligible for the salary claims. And then, yeah, hopefully you've seen in the document, there's a huge section on the types of costs you can claim on the award. And this is just a flavour of the types of things you can claim. I'm not anticipating that covers everything that you may want or need during the award. So this is just some general principles to bear in mind when you're drafting your proposals and pricing them up. So Wellcome usually only covers the direct research costs if it's essential to proposed activities and its deliverance, and all costs should be clearly justified within the relevant cost section for the proposed activities. So when you are costing, you should really bear these 4 points in mind. Like, is it essential for the proposed work? Will it best allow you and your team to deliver on what you're proposing? And is there kind of a clear project-related rationale for why you need said costs? And does it align with that general guidance and policies we have in place? And then for the indirect costs and overheads, you can ask for overheads on any part of your grant. It's subcontracted to any of the organisations listed below, such as universities outside of the UK. Research organisations do not receive core funding for overheads. Charity, social enterprises, non-governmental research organisations, small or medium-sized commercial organisations. And then the total amount we pay for overheads is just 20% of the total costs that would be directed to that organisation. And they must be clearly directly supporting the activities of the grant. Yeah, and then once they're submitted, again, Wellcome will go through all the proposal in more detail, and there will most likely be a lot of questions surrounding the costs. So again, try to justify those up front. It just prevents a lot of back and forth saying, why did you request this? Why did you need that? Yeah, it just helps to assure alignment with Wellcome policy. And I'm going to stop there. There's a super brief whistle stop tour of the document. I would encourage you to read that if you can. But yeah.
Thank you so much, Greg. So yeah, I've sent the document to everyone, and it's also available on our participant portal. So yeah, please, I encourage everyone to read it carefully. And now we can open the floor for questions. There's already a couple in the chat. Maybe I'll read them to you, Greg. So a question related to the teams. The guidelines mention staff like project managers. Should they be involved? Should they be included as co-applicants? What's the best way to highlight their skills in managing complex projects like this? So yeah.
If they're contributing, like their skills and expertise are essential for the deliverance of the proposal, and they're bringing like this expertise to help you like the actual like conduct the research, it may make sense for them to be co-applicants. But if they are almost just providing like a kind of like a service, like that managerial project support, it may make more sense for them to be employed as a member of staff on the award, in which case, like however time like FTE commitment they need to be costed onto the award to help you deliver on what you're proposing. Again, in the cost section, you can kind of like outline why you need this person to help you deliver. If you're working with like multiple countries, multiple partners, it may make sense to have a project support. So yeah.
Okay, thank you. Another question, and I think that this is a common one. From Lauren White, I noticed that PhD stipends aren't an allowed cost. Is this to discourage us from having doctoral students to work on the projects, or is there something about this I am missing? Thanks for the insight. So yeah, PhD student fees.
Yeah, so this one is more of a practical point in that the awards are up to 2 years in duration, and most PhDs will go on longer than that. So once the award ends, the spend will end. So you'll be leaving people in the lurch effectively. But we have other mechanisms in which people can apply for PhDs on, but just not for these awards, unfortunately.
Okay. If a small business was helping with both the research and the proposal writing, would that bundle into overhead costs or under the indirect overhead under small commercial organization?
So we would only be paying for, if I've understood this correctly anyway, we'd only be paying for the research costs of the proposal itself once the activities have begun. So we wouldn't be granting for work carried out in this period. I think that's a different thing entirely, if that's answering your question, Spencer.
Yeah, I think so. With your seed funding, you can use it for something like this, but not with the for the full award phase. Anyone has other questions? You can also raise your hand and speak if you wish. No? Okay. Then thank you so much, Greg. That was really helpful.
Thank you.
And I'll share my screen again now. And so now we'll do a very quick review of the results of the pre-workshop survey that I've sent to the team. So thank you so much to the teams who replied. And the idea was to highlight common practices and challenges across the teams in the project on project code and data management. And so your top challenges were sharing with collaborators. So how to do this correctly when there's restricted environments, when there's sensitive and often heterogeneous data, and complex governance between different institutions and countries. The second top challenge was about licensing and ethics. So again, working with sensitive health data, often protected health information, navigating IRB approvals, licenses for vocabulary software. So yeah, many things around that. And the last one was about making work open and reusable, so open science. So basically, how do you balance open science requirements with the privacy and ethical restrictions? How to ensure reproducibility while protecting sensitive data? And then the common tools across teams. I think practically everyone uses GitHub and GitLab for version control and codes. For data storage, many teams use their institutional servers, and a lot of teams also using AWS. And many teams also for data management are using Redcap. So then we also asked to the teams what they would like to learn today. And so the answers were best practices for open science and reproducible code. So while, again, handling sensitive data, ethical and secure sharing of sensitive health and clinical data. And this includes anonymization and privacy preserving methods. Then collaboration across institutions and restricted platforms, like I mentioned in the challenges. So how to align workflows and tools when sometimes raw data cannot be shared. Then practical approaches for AI and Gen AI, particularly research. So model deployment, bias mitigation, multimodal pipelines. And finally, effective data management and documentation. So this includes translating between different formats and creating good data sharing plans. So I think this is a very good to set the stage for our fantastic expert speakers that will share with you today practical tools and approaches for you to better do project data code management. So each speaker will give a short 10-minute talk, and I'll ask the speakers to try to keep on time. And then after the three speakers present, we'll have a time for a short Q&A. So let's start with Christopher Chambers, and maybe Chris, you can start sharing your slides, and I'll introduce you while you share it. So Christopher Chambers is a professor of cognitive neuroscience at the Cardiff University. He's an expert in open science practices, and as part of his work, he has co-founded a range of initiatives, including the Registered Reports and the Royal Society Replications Initiative. And so, we're very happy to have you, Chris, and over to you.
Thank you. Thanks, Joana. Nice to be presenting. I'm sure many of you who are involved in this scheme are considering the most open and reproducible format in which to present your design and your findings. And today I want to explain briefly how you can do that using one of the platforms that I created a few years ago called the Peer Community in Registered Reports. Now, many of you may be familiar already with the Registered Reports article type. So this was created around 10 years ago as a means of solving widespread problems we have in mental health research and much more broadly in terms of publication bias for positive findings and reporting bias, in which the incentive structure of academic science encourages the selective explanation and description of results which journals find exciting or novel or original. And registered reports try and tackle this problem head on by taking results out of the equation in peer review. So with the standard registered report format, researchers submit a study plan prior to completing the research, so pretty much at a stage you're at now, which undergoes stage 1 review, where reviewers assess theory, rationale, rigor, and robustness. And then on the basis of that evaluation, if positive, the plan is given in principal acceptance by the journal or platform, which basically means that the quality evaluation of the science has happened before the research has been done. This means when you're finished as a researcher in doing the work, you come back and submit a stage 2 manuscript reporting your results and findings. You cannot be rejected based upon your results, and because you've pre-registered all of your analysis plans and whatnot, it takes away a lot of the potential bias that you might have consciously or unconsciously in scientific reporting. So it really tackles bias control head on. And reviewers are brought back at that second stage, and if that all goes smoothly, then the final report is published. Now, registered reports have been around, as I say, for about 10 to 12 years, and they've been adopted by hundreds of journals, including some well-known high-impact journals. And the meta-science we have so far suggests that they're working as intended, exactly as we would hope to strengthen and reinforce this kind of research. So we're showing that we're finding that the format's popular with early career scientists. We're finding that when researchers do a registered report, they're much more likely to disconfirm their predictions. So we're much more likely to find out that we're wrong. And this is a promising sign that the format is working in terms of imposing some bias control on the scientific process. We're finding they're more reproducible and they're rated higher in quality and they're cited quite well. Just as a kind of snapshot of the early meta-science that's centered on the journal-based format of registered reports that you might be considering. However, I've been involved in this initiative for some years, and I've realized, based upon a lot of feedback, that the journal-based model isn't perfect. And there are four main limitations I want to very quickly cover. The first, and perhaps the biggest drawback for researchers pursuing a registered report, particularly for a project such as yours, which is 2 years in duration, is the stage 1 review time. The time taken to go through stage 1 pre-study review can take several months at a journal, and can, of course, interfere with other necessary activities as part of the research. A second limitation is that registered reports, just like regular articles, have to be submitted to one journal at a time, which can be inefficient, particularly if you get rejected from one journal and have to go to another. Third, many grant applications and indeed projects in general are well suited to programmatic research, where you might have one general kind of plan or protocol which could lead to multiple different articles. And at the moment, registered reports, as they were originally developed, based on a kind of simplistic one-on-one approach, where you have one stage 1 protocol leading to one stage 2 output, which isn't well suited to when you might have, as you might have, a program of work in mind, a single program which would lead to multiple outputs. And finally, the policies surrounding the use of existing data for registered reports are unclear at many journals. So the use of existing data sets can be a very powerful approach, as maybe some of you are considering doing for your work here. And it's not clear for many journals whether or not they will accept registered reports where the data already exist in some format and therefore might have been observed prior to submission of the manuscript. It's for these reasons that a few years ago we created a preprint-based evaluation platform called the Peer Community in Registered Reports, which sits above and beyond journals and evaluates registered reports, as I say, at the preprint stage before you submit it to a journal at all. So it's free, it's non-commercial, and it's basically dedicated to reviewing and recommending registered reports across all fields of research. And it's not a journal. So this is a really important point to emphasize. It's not a journal that doesn't index and publish papers, but it reviews and recommends the preprints that are posted on a preprint server or other repository. Now, once a registered report is recommended by PCI-RR after peer review, what you do as an author is you update and revise the preprint, and at the very end of the process, if the process goes well and there's a positive decision at the end, the peer reviews and that recommendation by the editor are published on the PCI-RR website. And the really key bit of this, the important bit that makes this very attractive, is that then you have the option to publish this recommended preprint in a traditional journal, and that includes a growing list of what we call PCI registered reports friendly journals. So these are journals that have committed to accepting the recommendations of PCI-RR without further peer review. So they trust that the PCI-RR process is good enough that it can replace the review process that would have taken place had you submitted your registered report to a journal. And the nice thing about this also is that because there'll be multiple PCI-RR friendly journals, that it puts you in charge as an author in terms of where you get to publish your eventual stage 2 registered report. So this slide shows on the left the current list of PCI registered reports friendly journals, which cover a kind of broad range of areas, including several journals which will publish in mental health and psychology and computer science. And we also have what we call PCI-RR interested journals. This is a smaller list of journals which fall into that more traditional kind of high impact, high prestige category. And these journals apply different criteria to the evaluation of stage 1 registered reports, which means they don't automatically accept our recommendations like the friendly journals do, but they do get advanced view of stage 1 manuscripts that have been accepted in principle. And what they often do, as we've seen, is they reach out and they make offers to authors like, we're interested in your registered report. Would you like to submit to us when you get to stage 2? And this can be also a nice way of making the process much more efficient, because your manuscript, having been reviewed and recommended, is now kind of potentially available to all of these journals at the same time, rather than going to one journal at a time. Now, in the workshop that follows, I'll go into some specific features of PCI-RR that are also particularly attractive, I think, and we're finding very popular. Two of them, just to mention very briefly in the time I have remaining. One of them is the programmatic format. So as I mentioned, one of the limitations of the standard registered report model is that there's a one stage one manuscript leads to one stage two output. But with programmatic registered reports, which you can only submit through PCI registered reports, you can have one programmatic large scale manuscript, which pre-registers essentially multiple stage two outputs. This can be a very powerful and useful way of having a whole lot of different research reviewed at once, and all of those stage two papers would then be accepted at the same time. And the second feature is scheduled review. So to speed up the review process, rather than going through this very linear kind of and slow serial process of submitting a full manuscript and then going through traditional peer review round after round, with scheduled review, what you do is plan the review process in advance. And so while you're writing your stage one manuscript, PCI registered reports and the recommender or editor is acquiring the reviewers to review at a future date. And based on this approach, we can then collapse that review process down to a very short frame of time. I'll stop there because I don't want to take up too much time, but to anticipate in the workshop, I'm going to dig into some of those additional features in more detail, including some ones I haven't talked about. And in case you don't make the workshop but would like to find out more about PCI, there's some more links on this page, and you can find my slides here on the OSF. So thank you.
Thank you so much, Chris. That's super interesting. If you have any questions for Chris, you can start writing them on the chat, and we'll move into the second speaker. So it's my great pleasure to introduce Sara Villa. Sara, you can start sharing your slides. So Sara is a research community builder and open science expert with a background in molecular biology, genomics, and healthcare. She leads training at OLS, the Open Life Science Community, and contributes to initiatives like the Turing Way and Data Science for Health Equity, supporting collaborative, reproducible research. So very happy to have you, Sara, and over to you.
Thank you so much. I'm very happy to be here and be sharing a bit more, I guess, unusual perspective on collaborative research and community engagement. But I'm happy to talk about anything related to open science. So you gave already a great introduction of myself. I'm Sara. I have been a researcher for more than 15 years. So my background is molecular biology, more specifically molecular neuroscience. I've been doing a lot of genomic analysis and research for the last 7 to 8 years, and that's how I became a bioinformatician myself, if I can call myself that. I've been always a huge fan of collaboration, even since I was a PhD student. And when I stepped into the bioinformatics field, is when I even came to believe more about collaboration and open science and open communities are the way to just build on these skills. So these are only some of the communities that I'm involved with in several capacities, mostly training and a lot of community building and engagement. And why I want to talk about open science. So just to clarify, I'll be referring about open science in a kind of an umbrella term. So like a full set of practices and skills aimed at making the research that we do more accessible, transparent, and collaborative. So not just about sharing data and making everything open access and open source, which is essential, of course, but also about open innovation, about participatory research and citizen science, or how to even make our training resources open as well. So the idea is to make everything accessible for everyone with all, of course, no price barriers, but also no access barriers, and that we focus on inclusivity as well. Why do we want to care about open science? So, of course, we just want to, this is words of UNESCO, like we want to make sure that not only the scientific knowledge, so the research outputs that we create are accessible, but also the production of that knowledge itself. It's inclusive, equitable, and sustainable. So what I'm going to highlight during my talk and also the workshop, I'll list the activities later, is that the goal of open science is not just being open, but it's achieving all that knowledge, all that research, all those projects in an equitable way and with diverse actors and stakeholders involved. So how does this look like in research and AI? So of course we want to be aware of the public benefit that we are thinking of. So the development should be driven by the needs, by the values, and the interest of people and the community. So all the expertise that you should welcome to your projects can go through domain experts, of course, like yourselves, but also users. Let's not forget the users, the contributors, if you are aiming to collaborate, data scientists. I mean, I don't have to sell this to you. Patients and public representatives, also policymakers, and many more. So like aim high for involvement, because the more involved and the more diverse that a project is, the more tight the research outputs usually are. So I want to encourage you to think, what does it take to drive research and AI forward? So in your own projects, what does it take to collaborate or to co-create with patients, with other PIs, with other analysts? What does it take to address societal needs or to innovate in a responsible way? The idea that I want to bring here today also, I think for what I saw in the survey, you all work very collaborative and in very multidisciplinary teams. What I want to bring here today is also to bring the idea of the diverse research teams. So not only a diversity in terms of fields and topics, but also in the professional roles involved in the research teams. So building teams with both specialists but generalists as well, embedding both technical and social experts. And this will provide the ideal environment for collaboration and engagement with a broader community. Researchers of these technical roles that you can embed within your proposals could be research project managers, which has been going around academia for a while, also RSEs, research software engineers, and I guess the figure that I want to highlight today is the figure of research community managers. So what is a research community manager? It's a professional technical role that fosters collaborative environment where a diverse community can access both the socio-technical infrastructure, but also the participatory processes needed to engage and gain recognition for contributors and build a shared agency over the research work. So RCMs do bring experience in both research and data and embed them and interact with the community interests. So what does it look like? A research community managers, in the end, it's a role that I think traditionally has been done by a lot of postdocs, a lot of also PIs in their roles. So of course they provide technical support, they co-create and maintain communication, they amplify and champion community, but they also facilitate the stakeholder engagement and collaboration. So it's roles that a lot of PIs have been doing already. But the more diverse a team grows, the more this kind of figure is needed. And that's why we for example, in our RCM cooperative is where we try to provide training for those acting as research community managements or provide support for those needing community management. We are actually more and more written on different research projects as your own to try to help embedding this kind of expertise in research, even at low levels. And I guess I want to highlight also one of the communities that I'm involved with, which is the Turing Way, which is the perfect example of both open leadership and community. The Turing Way brings both community definition as a market tool. So of course, a community in the sense that it consumes a brand, it consumes something and advocates for it. So for example, the Turing Way is a handbook that on good practices for data science. But we also believe in community in the sense of collaborative ecosystem. We shape the offering, we involve the community in this creation of the handbook. So it is a diverse community of contributors who collaborate to make data science more accessible, comprehensive, and effective. And this is just one of the examples that I want to bring with. So this is the classic mountain of engagement. So what we need, the steps that we need to think about when we talk about community and community leadership. So of course, think about the project, how do you reach about the right people, but also how do you bring them back? So if you are talking to other collaborators, to other contributors to your project, how are you going to bring them back, and how do you make it sustainable and resilient? And these are some of the things that we will be touching in the workshop activities. So maybe think about what is the purpose of their community, and I'm saying community in the sense of overall project. How do we apply systems thinking on stakeholder engagement and management, and also maybe the skills and competencies that you need to bring to your own projects to make them successful. And that would be it for me. Thank you.
Thank you so much, Sara. Really interesting for these teams that are so multidisciplinary. If you already have questions or comments for Sara, please feel free to write them in the chat. And now we'll go through our third and final talk. So it's my pleasure to introduce Sara Gibson. So Sara is a software developer and a cloud infrastructure engineer, passionate about scalable, reproducible research. She develops cloud-based solutions that help researchers share and reuse data, code, and analysis transparently. So thank you so much for being here, Sara, and over to you.
Hello, yes, thank you very much. I'm just winding myself to the start of my presentation. So hello, as mentioned, my name's Sara. I'm a DevOps and platform engineer with a background in research. So primarily astrophysics back in the day, and then I became a research software engineer at the Alan Turing Institute, doing a lot of very cool projects, one of which was the Turing Way, which Sara gave a really great introduction to. And I am the co-lead of the infrastructure working group at the Turing Way. So I'm responsible for keeping the lights on and keeping all of the resources available, and how do we facilitate new contributors and all that kind of stuff. I'm also a former operator of the website mybinder.org and contributor to the Jupyter Hub project. And Binder and Jupyter Hub, to some extent, will be the content of my talk today. So, Sara gave a really great introduction to the Turing Way. Just to reiterate that, we are an open science, open collaboration, community-driven project to involve diverse community of contributors, making data science accessible, comprehensible, and effective for everyone. And that's really reflected in the growth we've had. We've been going for 6 years now. I've been in it for the long haul. I was part of the original team before we were even allowed to talk about what the Turing Way was. I was there. We've expanded into 6 guides, over 300 chapters, over 500 co-authors, 6,000 and above monthly users, informal collaborations with 10 different organizations, and citations in peer-reviewed papers and all sorts. So if you're wondering about best practices in various areas, the Turing Way is probably the place to go. And if you're not finding what you're looking for, that doesn't mean it's not a best practice. It could mean that folks like you are just not represented in the community yet. So we would love to have you and fill that need. I'm gonna start with a definition of reproducibility, and this is what I am going to be referring to as reproducibility during this talk. So it's in this top left quadrant. If I have the exact same data set as you and I follow the exact same analysis steps as you, then I should get the same result as you. That's not to say that other areas on this table aren't interesting. So replicable, if you run the same pipeline on a different data set, it's interesting if you get the same answer or not. That's a really fundamental part of science. Or, robust reproducibility, like if you write your code in Python and I write my code in R, and we do an analysis by hand all on the same data set, do we get the same result? What's different? So like we're not being specific about how the code is written. And then all of that feeds up into generalizable. And you need the previous two, replicability and robustness, together to be generalizable, but this is not generalized. It doesn't apply to all researchers, but it's a step towards saying it's not something specific about this data set, and it's not something specific about my code or the particular version of my code that allows us to be able to like stand on the shoulders of giants and do really important work. And I'm going to go even further in this and define exactly what I mean by reproducibility here, which is this little sub-box repeatable. And this is like literally getting the exact same answer from the same data set on this run through the same code. Like I'm talking to decimal figures. It's not the same as reproducible because repeatable brings in the concept of the computational environment, whereas reproducible only relates to the data and the analysis steps. And Binder, the tool that I am going to be talking about today, it captures that repeatable aspect by adding in the dimension of what's going on in the background. And I've had some people say, well, maybe, it's not helpful to like, get the exact same answer every time, And what I would say to that is that the thing I'm trying to advocate for here is noticing when your pipeline produces a different result and being able to explain why. That's good science. If you can explain, yes, my numbers changed because, that's fine. If your numbers have changed and you can't track down why, it's not a reasonable foundation for us to go and create further science on. I probably don't need to talk to this group about why reproducibility is important and the effects that this can have, that errors in the scientific literature can have on the real world, but I'll just run through a quick example here, where on the left here, we've got a spreadsheet with some numbers in it, and some of those numbers are highlighted. And what this was a study into countries' GDP growth, and the result of this paper led to a lot of policies being put in place in different countries around the world, the UK included, that supported austerity measurements and had a big impact on some of the most vulnerable in our societies. And then on the right, we have the news article here, which is of the PhD student who was able to get a hold of this data set, rerun the analyses, and realize they got the number wrong simply because when they highlighted their numbers in their Excel spreadsheet, they forgot to highlight the last 5 numbers. And if you included those 5 numbers, you got a very different answer that did not actually support the austerity measures that were put in place in many countries. So this is why reproducibility, being able to identify where numbers came from and what caused them to change, is so important. So why aren't people doing reproducible research all the time? Well, there are a lot of barriers to it. There's a lot of fun things we can talk about on this slide, and I'm sure that people in the audience could recognize them. I'm going to talk about requiring additional skills and taking too much time to get over that hump of getting into doing reproducible research. So I have an example here. We've got a researcher, Jane. She's written a paper based on her experiments, and she would like anybody to be able to reproduce, check, and improve her calculations. So she goes through a process. The first thing she does is she describes her experiments as a Gibson notebook or a script. She mixes prose, code, visualizations together and adds any extra resources like source code, data, media. The next step she takes is she publishes that on a publicly hosted repository, in this case. She then describes the software required to run that environment and make it binder ready by including a configuration file. And when I say configuration file here, it's nothing special. If you're writing in Python, it could be a requirements.txt file or a pyproject.toml. This is a description of your software environment. And then by doing those things, everyone can now run and reproduce her computations around the world. Hooray. So just breaking down a little bit what happens there. You take your repository as if it's on GitHub or something, and you put it into the MyBinder UI. I've got an example here. Yeah. And the first thing that happens is your repository is cloned. We have a tool then called Repo to Docker, and this builds a container image of your repository according to the instructions contained within the repository. It then executes this image using Docker. We have a Jupyter Hub layer. A Jupyter Hub is matching people to computational resources. So it allocates some computational resources. In the case of mybinder.org, this is in the cloud. It then makes the image that is running, the container that's running, accessible at some URL, and then redirects the user's browser to that URL. And what you can then get is an experience where you have a defined URL that you can share with someone, and they can launch their computational environment, your computational environment, and access it in the same way. And this utilizes a lot of open source technology. Jupyter itself is open source. In the cloud, this is running on Kubernetes, open source. Repo to Docker is open source. This allows you to be cloud agnostic. It's also a tool that is free to reuse and modify, and allows you to decentralize power as to like which cloud vendors you're allowed to do this kind of work on. And I said a lot of the word public there, and you're probably all, oh no, but we're doing health data, and that's really, really difficult. It is, I'm sorry. But the great thing is it's open source, which means you can actually take a copy of mybinder.org, deploy it for yourself, and put in the required safeguards to make it private yourself. So in our breakout activity, we'll be building our own binder repo on the public mybinder.org instance, and we'll be following these instructions in the Turing way here. So you just need a small amount of code and data to be able to participate in that. And that is the end of my talk. Thank you very much for listening.
Fantastic. Thank you so much, Sara. I hope that some people brought a little bit of code. So now we have some time for a short Q&A. Yeah, so if you have any questions for the three speakers, any of them or all of them, comments, please, yeah, raise your hand if you want to speak and introduce yourself, or write them in the chat. We already have a question for Sara. So does the code for the workshop need to be as a Jupyter notebook?
No, it can be a script. People assume that to use Jupyter, you have to be running notebooks, and that's not true. And in fact, you can deploy a Jupyter Hub that doesn't use a Jupyter interface. You can have like a Linux desktop as well. So yeah, so long as it's some code, it doesn't have to be a notebook.
Okay, great. The other question before, these examples all assume Python. What about R and RStudio, which is commonly used for open reproducible stats and data science? It didn't seem well supported the last time I tried Binder.
So there was, fun fact, Jupyter is actually a portmanteau of Julia, Python, and R, and also includes kernels that support C++, Fortran, and multi-language environments. So it's a bit of a urban legend that Jupyter is only a Python tool. As for R code on Binder, historically, yes, it has been very difficult to get R environments up and running, but there was a big overhaul a few years ago where we switched over to the RStudio package manager as opposed to the Microsoft mirror of whatever the previous package management ecosystem for R was, I've forgotten, sorry. And that has improved the usability of Binder for our users.
Okay, great. Thank you, Sara. Any other questions for our speakers or comments? No? Okay, if not, we'll move into the breakout rooms and I'll explain how they will work. So now you'll have the chance to practice using some of the tools the speakers mentioned and share current challenges. So we'll have 40 minutes. This time you're welcome to select the room you want to be in based on your interests. So look at the bottom of your Zoom window for the breakout room button once they will be open. So you can choose room 1, 2, or 3. So room 1 will be with Chris Chambers on the register reports and open science in practice. Room 2 with Sara Villa with collaborative tools in research projects. In room 3 with Sarah Gibson with the reproducibility in action with binder and workflow tools. I'll ask you to please try to spread evenly across the room. So if you have more than one team member here, maybe try to split your team. If a room feels too crowded, please consider moving into another room. So yeah, try to keep a balance between the rooms. The idea is that the sessions are quite interactive and guided by the speakers, and we'll be jumping in and out of the rooms to make sure everything is fine. As usual, please use the chat to share your reflections, your questions, your insights. Yeah, try to get feedback both from the peers and the experts. So yeah, make the most out of your sessions, and also you can jump a little bit between sessions if that makes sense for you. So I'll ask Laura to open the 3 rooms now, and you're happy to. You can choose the room you want to be in, 1, 2, or 3. And we'll see each other in 40 minutes. It's difficult to organize a session on project data code management because there's so many different topics. But we hope that in between the 3 different talks and breakout rooms with the guidance from Wellcome, that you'll be able to really do something good with your outputs plan. And so now I would like to invite maybe the experts from each of the room just to share a little bit the highlights for each room. Maybe we'll start quickly with Chris, because I know you have to leave a bit earlier, Chris. Anything you'd
sure,
like
happy
to share?
to. Yes, we had a very quick fire discussion about a lot of the details of registered reports. It goes so quickly, doesn't it? I think we could have talked for another hour, really. I think that the main issues that came up were timing. So is there sufficient time to do this? Particularly, I think with a relatively short-term project like this, is a registered report feasible? And hopefully, I convinced some of you that if you go down the scheduled review track, this is a possibility. There is even, and I didn't get a chance to mention this, there is even the possibility of submitting to PCI registered reports before you have funding. We do in some cases allow this to happen. So if you, particularly because you've got a decent shot at getting a large grant now, you might want to, if you have questions in that regard, just get in touch with us at PCIRR. We talked about analysis of existing data quite a lot. So there were quite a lot of questions about under what circumstances a registered report would be suitable for analyzing existing data. And at PCI registered reports, we use a taxonomy for bias control, a level-based taxonomy, which involves 6 levels, where you have basically increased levels of observation and analysis of data before getting in principal acceptance. And it's just really transparent about the level of the risks of bias that are involved. And so there are a few questions about what levels would apply to different scenarios, and also about how journals consider the recommended preprints that come out, and how, to what extent they consider impact and so on in evaluating those submissions. And the main take-home message I'd say to anyone is, if you use PCI registered reports, the PCI registered reports friendly journals will never select based on those criteria. They use the same criteria that we use, which is we don't actually care about impact at all, which might sound strange, but all we care about is scientific validity, and we leave impact for others to judge. And the friendly journals endorse those criteria to the exact same extent, but other journals may do other things. So yeah, pretty wide-ranging discussion. And as I said to everyone in the breakout room, I'm always available if you've got any follow-up questions between today and when you eventually, if you do decide to go forward with a RR.
Fantastic. Thank you so much, Chris. Over to you, Sara Villa.
Thank you. Yes, I think we covered quite a range of topics actually in our session. It was quite organic. I think people are very interested in involving communities and patients, all types of people in the research. We had a bit of discussion about how to do that. And yes, I had a lot of input from the room, so cannot ask for more. I hope that was useful. We didn't cover actually all the materials that I brought to the workshop, so they are there in the chat. In case anyone is interested, just feel free to ping me.
Thank you, Sara. And finally, the other Sara, over to you.
Yeah, and we had like a self-driven walkthrough of building your own binder repository, and I was kind of like on hand to answer any questions. So we had like a few technical questions on how do I do this? Why is it taking so long? What's actually happening while I'm looking at this progress bar kind of questions. But we also had some like wider reproducibility questions as well around like data sharing, especially for sensitive data. And there was a good question as well on like reproducibility when things you rely on kind of disappear. And I think there was like two really important perspectives to take away from that question. One being when you're building systems and there are going to be components that you're not going to build yourself, try and choose open source tools, because at least if they do become unsupported, they're still in the public domain, they're still available to be looked at. Someone else could resurrect them, whereas proprietary software, some CEO can decide it's like not existing from tomorrow onwards, and you've got no blueprint to work off of to find a drop-in replacement or something else. And the other aspect of like, well, what happens if something disappears somewhere down the future? How long are we promising things are going to be reproducible for? Because there's actually not a lot of support and maintenance for long-term maintenance of projects at the minute, and that takes people and resources and money. And if the funding you're getting is not explicit on, it just says it needs to be reproducible, but it's not explicit on how long for, be explicit of how long you're committing reproducibility to be for, because it is a labor keeping things up and running for a long term, and people should be paid for their work.
Thank you so much, Sara. And now I would like to open the floor for questions or reflections from the participants. So please raise your hand if you'd like to speak and introduce yourself, or pop any question you have in the chat for the speakers, for your peers. Anyone would like to share anything from the breakout rooms? No more questions. Also, if you still have any questions for Wellcome, also feel free to drop them in the chat and we can go over this. Thank you, Chris, and thank you, Sara, and thank you, Sara, for sharing all those resources. Okay, so if there are no questions.
Small update from my build for Sara.
Yeah.
It worked, so it's working now. So thank you.
Fantastic. Okay, so thank you, everyone. Thank you so much to our speakers. I hope it was useful and fun. And so now, just before we end our workshop, I just want to go do a little walk through our program timeline. So our next and final workshop from this series will be on the 2nd of October. It will be a very important workshop focused on ethics. Then we'll have at the 6th of October this point for meetings for a midpoint check, and people were questioning before about the seed funding. So we use more or less the same parameters than Wellcome. And so when you asked for your seed funding through the request form, if there's nothing that we flagged to you, it's because everything you asked is eligible. But during October, we'll have these meetings to go through what you've asked for the first tranche of the seed funding and what you'll need to ask for the second one. And so we can go through all your costs for the seed funding. So we'll email you about these quick checkpoint meetings this week. Then you'll have also the opportunity to submit a draft of the proposal you're writing for Wellcome on the 13th of October, and we'll send you the form for that also this week. So this is not mandatory, it's completely optional, but I think it's a good opportunity for you to receive a little bit of feedback. And also, if you do submit these pre-proposals, the Wellcome team, they will also do a quick check just on if they're still within remit, so that can be useful. As you know, we'll have our in-person event in London at the start of November, so all the lead applicants must have received a formal registration from Wellcome. So if you haven't registered yet, please do. Up to 2 people can come in person and the rest of the team can join online. So we're very excited about that. Yeah, and then of course you'll have your deadline for the proposal, and we'll ask you for a final very light report at the end of December. And so with that, it's the end of our workshop. Today we end a little bit earlier. So a few quick reminders. So all the resources about the accelerator are in the participant page that Laura just put in the chat. Please, very important to us, fill in the feedback survey. Not a lot of you have been doing this, and it is really important for us. It will really help us improve the format of the sessions. Yeah, and continue exploring other tools, other strategies, things that we discussed today. Read very carefully the Wellcome participant guidelines, and if you have any questions, write to me. Yes, and so on behalf of Wellcome, Neuromatch, a huge thank you to everyone, to all the speakers, to the Wellcome colleagues, and yeah, all of you for your participation and for your engagement so far. And yeah, we'll see each other at the next accelerator event. Thank you, everyone.